Hi, fifth graders. I hope you had a great weekend with your family celebrating the holidays and you got some outdoor time with your loved ones and all that good stuff. We left off last week with multiplying fractions and we're going to be sticking with that. However, last week we did a lot of work with models of fractions, and today we're going to show you how you can just use algorithms to solve these same types of questions without actually relying on any modeling. Okay, so I'm going to show you some examples of multiplying whole numbers times fractions. And as the week progresses, we'll get into fractions times fractions, mixed numbers times fractions, and all that stuff. But for today, it's going to be a fraction times a whole number. And just to show you quickly what that would be, something like 5 times 1/3, a whole number times a fraction. Okay, so we're going to start by reading a quick word problem and then taking it apart. Okay, so in this question, Trish bought 4 yards of yarn to knit blankets. She used 2/5 of the yarn to knit a hat. How much yarn was used to knit the hat? Okay, so she had a total of 4 yards and she used 2/5 of it. So hopefully you can identify which is our whole number and then which is our fraction. So we want to find 2/5 of the 4 yards. So to do that, we are going to write an equation. We are going to find 2/5 of 4 yards. Now, if we wanted to model it, we could draw 4 holes, shade in 2/5, 2/5, 2/5, 2/5, and find out how many fifths we had total. Here, we're going to use just an algorithm. We are going to take the total number of parts that were used, 2, of the 4 yards. So I'm going to multiply my 2 times the 4 yards I had, which gives me 8. But now I need my denominator. That's going to give me my numerator. My denominator is still the size that I was using. I was using fifths. This is my unit. So my unit is not going to change right now. It's going to stay fifths. So it's 8 pieces that were fifth sizes. So 8/5 total. Okay? Now to make this a mixed number, 5/5 would be 1 whole, right? But then I still have 3 more fifths, which would bring me to the total of 8/5. So I'm going to have 1 whole and 3/5. 1 and 3/5. Now, for some people, they look at this number. I'm going to rewrite the same exact question. 2/5 times 4. And it makes them a little uneasy that this doesn't have a denominator. I want to tell you that even whole numbers can be given a denominator and keeping this still 4. Think about what number could I put under here as a denominator. That something very important you have to remember. A fraction line is a division sign. Mr. Corso's favorite saying. Fraction line is a division sign. So 4 divided by what number would still equal 4? 1. So if you're uneasy about leaving that whole number without a denominator, you could give it a denominator of 1 every time. And then I could say 2 times 4 is 8. And then 5 times 1 is 5, and it still gives me my 8/5. So if you're not comfortable with just leaving it as a whole number, that is another option. Let's read another question. Mrs. Sawyer bought 6 one-pound bags of jelly beans. She used 4/7 of each bag in Easter baskets. how much of the jelly beans were used in the baskets. Now I want you to, I should have brought it up in the last question, but I'll bring it up now. She has 6 1-pound bags. So how much does she have altogether? 6 pounds. Now, if she used all of the jelly beans, that would be 7 sevenths. She would use how much? 6 pounds. She didn't use all of it. She used a little bit more than half. So here, 6 pounds, if I used all of it, my answer would be 6. But I used just a little bit more than half. Well, half of 6 is 3. So your answer should be a little bit more than 3 for accuracy. So let's try it. What is my equation going to be? Can you find the whole number? 6. And can you find the fraction? 4 sevenths. So 6 1-pound bags, and she used 4 sevenths of them. So I had used 4 sevenths of each bag, but I had 6 of them. So 6 times 4 is 24. And what size were they? Doesn't change. Sevenths. So it's 24 sevenths. And before I said your answer should be a little bit more than 3. This doesn't look like 3 because it's not a mixed number. It's an improper fraction. We have to change it. So I could say 7 sevenths, 7 sevenths, 7 sevenths, or I could just say 24 divided by 7 is going to give me 3 wholes. That gets me to 21, 22, 23, 24. I'm going to have 3 sevenths left. And look, our answer is 3 3 sevenths, which is a little bit more than 3. So my answer seems accurate. Okay, I want you to try now. Mike exercised for 3 hours. He spent 2/3 of the time running. How many hours of exercise did Mike spend running? Write your equation and solve it. Okay, if you need extra time, press pause on your screen and you can always resume. So 3 hours exercising, 2/3 of the time was running. So I need to find 2/3 of 3 hours. Now, listen carefully. Let's say your equation said 3 wholes times 2/3. Luckily, this is multiplication. So we can use the commutative property. We can switch the order of those numbers and we're still going to get the same answer. So if you have 3 times 2/3, you'll still get the same product as me. Okay, so 2 times the 3 wholes is going to give me 6. And what size are they? They were split into thirds. So 6 thirds. My numerator is bigger than my denominator, so it's improper. So I'm going to turn it into a mixed number. 6 divided by 3 equals 2. So 2 hours. And does it make sense? Well, let's see. If he spent all the time running, he would have ran for 3 hours. He didn't spend all of the time, but a lot of it. So 2 hours is an answer that seems reasonable. Okay, so what if we see questions that don't have any type of word problem and it's just an equation? How do we solve that? Same. Gonna look at my numerator. That's how many parts I had. 5. How many times? 3 times. So 5 times 3 is 15. And what size were these parts? They were 6. So 15 6. How can I change that into a fraction? A mixed number. I'll show you another strategy. make groups of 6 until I get to 15. So that's 1 whole. Another 6, that will be 12. That's 2 wholes, and then I still have 13, 14, 15. Oh, so I still have 3 6 left. So I would have 2 wholes and 3 6, and we can reduce 3 6 to 2.5. Okay? Watch me do another one. 4 wholes times 3/4. I have 3 parts. How many times? 4 times. So that's 12. What size are they? Fourths. Or what's my unit? Fourths. How can I now turn this into an improper fraction? A fraction line is a division sign. 12 divided by 4 equals 3. Okay, and remember, if I started with 4, I didn't use all of them. That would be 4/4, and my answer would still be 4. I used a lot of it though, so it makes sense that my answer could be 3 wholes because that's pretty close to 4, but not all of it. Okay, so check for reasonableness. Try on your own. Here we go. 2/3 times 3. All right. I had 2 parts 3 times. That's going to be 6. And remember this strategy I taught you before. If you feel uncomfortable having this 3 just floating there, you're allowed to give it a denominator of 1. Because 3 divided by 1 is still 3. It doesn't change the value of that. So now 3 times 1, 3. You have 6/3. Improper fraction, turn it into a mixed number. 6 divided by 3 equals 2. Let me check for reasonableness. If I had 3/3, I'd have all 3 of them, but I only have 2/3, so 2 seems like a reasonable answer. If I got 6 or 9, that's not reasonable because I only started with 3 to begin with. Okay, and the last one. 6 times 1/4. Okay. I had 1 part 6 times. That gives me a numerator of 6. And they were fourths. So 6/4. Divide it. 6 divided by 4. 6 can go into 4 one time. Or 4 and then I have a leftover 2, a remainder of 2. And they're still fourths. If I want to simplify, 2/4 is equivalent to 1/2. So 1 2/4 or 1.5. And look here, I started with 6. I didn't use that much of it. I only used 1/4 of it. So does it make sense that my answer could be 1.5? Yeah, because it's not that close to 6, right? And if it was times 0, it would be 0, but it's a little bit more than none. Okay, so that's how we multiply whole numbers by fractions. And remember, it's okay if you reverse the order of your factors because it's multiplication, you'll still get the same product. All right, and lastly, you can always add that denominator of 1, multiply straight across. 2 times 3 is 6, 3 times 1 is 3. All right, do yourself a favor and check your answer for reasonableness. Does that make sense? That'll give you a little bit of a head start and a little bit of a confidence moving forward. I miss everyone. I am looking forward to having another meeting with you this week. Check your Google Classrooms for the link. I think it's likely going to be Wednesday. So keep your eyes open for that. And I can't wait to catch up with you guys. See you soon. Bye.